Welcome to another episode on my Arduino Mega2560 and Arduino Uno, connected through SPI, and with lots of electronics and fischertechnik mechatronics. My idea was first to continue with the SPI first to get the code as I wanted. However, there is something I really missed in the electronics, and to explain that I need some clarification, and that is that whenever you use a transistor to control a motor, there occurs a peak current, and in time it can destroy the transistor. The peak can be eliminated by using a diode, and that is exactly what so far is missing in this whole circuit. I do have light emitting diodes, but I don't have protective diodes. And to show, let's go to the schematics. So this is a diode in protective way that it is parallel to the motor, because that is important. The motor is going from collector to the power, and the diode has to be parallel to it, so collector to the power, and that goes for all the motors. So although they may not seem to be parallel, they are all parallel. The only point is I haven't placed them yet. So that is also the reason why I have not powered up the whole system. And well, while you can see the symbol, it is like an arrow with a bar. This is a real diode, and the gray line, not sure if you can see it properly, there's a gray line on it, which is that bar, so it bars everything from one direction. And if I look here, then this is the collector, so I have to make sure that the diode goes from the collector to the power, and in this case that may give a little bit of a problem in available space, so I probably have to relocate this wire here, and then put this diode from here's an obstruction, so let me take another one, and it goes from here to here. I hope, yeah, and that's the position. So it speaks for itself that for this motor it will go the exact same way. A replacement of this wire, right, oops, to this location, and then let's see if I can get it in anyway. That proves to be hard, so I need to change that. Then let's see if this one will. So here goes, and that should fix the diode problem for 2 motors, which means I have to fix this one, which is a little bit thick on one side, but the other diodes I have to fix as well in some way, because I scavenged them from other circuit boards, and this is the way they were put in, so perpendicular to the board and not parallel. So that is not going to be easy, but let's see how I can fix this. Anyway, this is the way it should be for this motor here and for this motor right here. Okay, that is done. Once again, I had to improvise with staples, and if you have watched my previous videos on this and other videos, you know I'm no stranger to improvise with staples. And after these diodes I had to rewire a bit. Well, these I had to rewire as well, both of them. Then I had to rewire here, here and here. So this wire, for example, has gone from front. Oh, no, it is still in the front. There was one possible one pin left in front, so that was not a rewiring, but here I had to rewire from the front of the transistor to back, and it is one connected lane, so that's no problem. And you see here the shiny part, which is part of the staple that I cut in two and then soldered to the diode. And here I had to rewire from front to back to the transistor, collector still, and then here again with other half of the staple, and then taking care of course, the correct direction of the diode. So now they are all as intended. And yes, that also means that the Arduino Uno, which I haven't loaded yet, that's a good one. Well, this one, I still need to do a staple, to create a staple, a diode here. So let me do that. And that diode will have to be, and it turns counterclockwise, which is a bit cumbersome to do, but it's the way it is. And then I'll have to do it right here. So I can turn it once again, by the way. and do it here. Calling it diode 1 for the Uno. That's one. That one. And now make a connection here, here and here. That one. And that's the other one. So now all schematics have been done. That's nice. So with that it is actually time to power up and see if everything works, which should. Question is, will it? And experience learns that I should first power up the Mega2560 and then the Uno. And so far I find that even much less is working now. This one works. This one shows no activity at all. Why is that? Not a very good sign. Ah, right. Oh dear. I should move this wire even more. Or not. This works. This motor still doesn't budge, and this is working. So although some things work, this motor still doesn't bother. This motor here does. Let me point at it. You see it run, and the rest unfortunately shows no difference. Right, with the SPI in itself working and the SPI working, I should look at the coda, but the motor is still not functioning despite efforts. And that is bothering me. Also with this motor, of course, everything works. Last time I put this spot meter in, which controls the value for the output here for this motor, and that is the same range now. because this is a much higher range potmeter than the smaller one, which is still here, not connected now. So when I start the serial monitor, I get potmeter value 737, 729, 73s. So that in itself is a nice value. And then the output value is 183. So remember, around 730, 733, and around 1730, no, around 730 and 180. So let's go here, and that has to be this one. This has to be this one, and let's and we have to pause for some more info. Potmeter value is 300 higher. Aha. Output value is higher as well. Was 180 on the Uno, 250 here, but this is remarkably higher. And when I go here to find the value, that brings out the problem. So how do I get a 1000 value where I get in maximum value here 730 something? I do not have another potmeter like this, so that's a problem. Also, with this LED not burning here next to the transistor, it is next to impossible to have things working. And the value, output value of 180 on the Uno is lower than 256, and with 256 it works. What I can do, of course, and will do, is raise this value from 180 to see when it exactly is enough to get that LED burning. So for now, no potmeter value, but an analog one, and from 180, which does not do the job, I go to 250, no, to 200, not 250, uploading, and that doesn't do the job on the LED. So I increase by 10. Not doing the job. This is interesting. And with these values the LED still does not shine. Not even now. I'm starting to wonder if I did anything wrong at all. Now it does, so I'm going down. Nope, 250 is not enough. 255 is enough. 54 is enough. 250 is the absolute limit. You see it well, go on and off. So that means that that the output value of 180 is too low, which indicates that this potmeter is not suitable. It is 70 too low. Ouch. What to do about that? While still on the search for a potmeter like this one, I have further experimented on the value for this LED, which is basically not this one, which is basically this LED. No, this one. And you see it shine. It's burning brightly. But the value is 180. And if we go to the output value, then we will notice that it is 182. So with a value of 180 the LED burns brightly. So in this situation with and that is the output value here from the potmeter, that it should work. Everything this works. Is it enough for the motor? That is very interesting and intriguing, and the best I can do, or the fastest way to find out, is to turn this to the lowest value possible that it runs. On the other hand, it did run even without the potmeter, which has the maximum value then. So, still a lot of questions. But now, first something different. Let me close this monitor. What I wanted to do as well is find out on using the feedback of the SPI. So what is the feedback of the SPI? Well, according to this all, and let me change this so we know for sure. Yes, now everything is for 2560 serial motor. So from SPI is the text to look for. And serial print. Here it is. Much higher than I thought it was, but it receives from this. Now what is it if I change it by, not that one, this one, if I press this switch? And don't touch it too much. So what will be the difference? What is the difference anyway? That said, if I look here, I should see some kind of difference. So I'm pressing the switch now since the motor doesn't run. There it goes. So you see first on the screen and then on the oscilloscope, but there's no change. So let me release it for now. And it stays the same. I press it. Have to wait a bit. No change. So either way, something has to change on this side and on that side. Last part of this video, of this episode. Last time I put this procedure, this if statement, also in here, and that is causing confusion because now I do not exactly know, apart from this line, when it is being executed. So I will remove this one and I will comment it as a block, upload it again, and what I also did just now is change the 0 to 0x capital B 0. This actually is hexadecimal notation. Since it is a byte, I want to know what effect this has, if any, on the Mega2560 guide side. So this is going to be an interesting thing to watch. This will be the Mega, the port will be Mega, everything is Mega, serial monitor, and I am afraid it doesn't make one single piece of difference. Nope, not this one, this one. So, and it is about being high. So I'm pressing the switch. Digital 9 should give high, and that's the big question, because that is a matter of timing. It is high. Digital 9 is high now. But what does the rest do? I have to look for from SPI, and SPI says it is 10. And the point is, if you convert hexadecimal B to decimal, you have 11. Since this says 10 from SPI, it's not good. Also, I keep pressing the switch and it says 10. It says digital 9 is low. So it's again timing. Timing is everything, especially here. So I think I should change my algorithm a little bit, but that will be for next time. So thank you for watching. What did I do? Put the diodes in, checked this LED, which in the end didn't matter in value anyway, and due to the placing of the diodes I had to rewire a bit, and finally some recoding. So once again, thank you for watching. If you like this video, please subscribe to my channel if you haven't done so, and like. Follow me on Twitter, retweet and like. Follow me on Instagram and like. And please donate to keep videos coming your way. More information on my website. And this is going to be continued. Bye bye.